Hello again, ladies and gentlemen. It's Johnny here looking at 20.5 problems. This first problem is going to kind of set the tone for the rest of the problems. The relationship between relationship between the change in Gibbs free energy and the EMF of an electrochemical cell is given by the equation in choice E. Delta G equals negative N F E, where N is the number of electrons that are being transferred. F is the Faraday's constant, 96500 joules per mole volt, and E is the the E naught of the cell, the electromotive force of the cell, so the voltage essentially. We're going to use this in most of the problems that are coming up. So which of the following reactions will occur spontaneously as written? It says refer to the table of standard reduction potentials. So what you're going to have to do is you're going to go, all right, well, what's being oxidized, what's being reduced here? Thing being reduced is iron from +2 to 0. So you go, well, what is the reduction potential for that? Negative 0.440. And what's being oxidized? Iron again from +2 to +3. And what is the potential for that occurring? And you look it up, it's negative 0.771. And that's going to give you a negative voltage. So this would not occur spontaneously. We're going to do that for the rest of them. So how about this? I'll give you the values, I suppose, and you can figure out which ones are going to be positive. So here, the reduction potential, what's being reduced? Well, iron is going from 0 to +2, so that's being oxidized. The chromium is being reduced, and you look up, well, the reduction potential for that is negative 0.74, and the oxidation potential would be positive 0.440. Overall, it's going to give you a negative voltage, right? Negative 0.74 and positive 0.44 is still going to be negative. So this isn't going to be spontaneous. But when you get to C, you see that the thing being reduced is the SN goes from +4 to +2. And the reduction potential for that is 0.154. Thing being oxidized is chromium from 0 to +3. And that is going to give you a positive 0.74. And that's going to give you a positive voltage. So this would occur spontaneously. So positive voltage equals spontaneous, right? Which is the opposite of the Gibbs free energy. If delta G is negative, then it's spontaneous. If the voltage is positive, then it's spontaneous. And when you look at the equation that relates the two, it makes sense because it's negative NFE. So F is a positive value, N is always a positive value. So this E, the voltage, is going to determine, if delta G is positive or negative. Because of this negative sign, if that E is positive, then our delta G is going to be negative. So both would be spontaneous. If E is positive, then it's spontaneous. Delta G is negative, it's spontaneous. 3. The standard cell potential for the reaction below is 0.126 volts. What is the delta G naught for the reaction in kilojoules per mole? So delta G equals negative NFE. Plug in what we know. F is 96.5 when we're doing the kilojoules. So it wants it in kilojoules per mole. So kilojoules per mole volt. The E they said was 0.126 volts. And now this N here, we got to figure out how many electrons are being transferred. This one's not so bad. You can tell that lead's going from 0 to +2. So that's a 2 electron transfer. And you can confirm that by looking at 2 hydrogens going from positive to 0 is also a 2 electron change. So the N here is 2. So you multiply all those together and you get a delta G of negative 24.3 kilojoules per mole. That's it. It's not so bad. It's just using that equation. Another one. The standard cell potential, E naught cell, for the reaction below is negative 0.55 volts. What is the delta G for the reaction? So it wants this one in joules per mole. So we go, all right, delta G equals negative NFE. So how many electrons being transferred? Well, let's see. I2 goes from 0 to -1, 2 -1, so that's in a 2 electron change. Let's confirm. We look at bromine, goes from negative, there's 2 negatives, to Br2 0, which is also a 2 electron thing. So we have 2 electrons. So 2 times In joules per mole, it's 96500 joules per mole volt times the E0 cell of negative 0.55 volts. And what do we get when we plug and chug those? You have 1.1 times 10 to the 5th volts. Big number. Cool. Number 5. Standard cell potential for the reaction below is negative 0.34 volts. The value of delta G for the reaction is what? In kilojoules per mole. So again, delta G equals negative NFE. Negative NFE. So how many electrons are being transferred? Well, Cu goes from 0 to plus 2, so I know that's a 2 electron transfer, confirmed by looking at the H's. 2 of them go from positive to 0, so that's a 2 electron thing as well. So we have negative 2 times, in kilojoules, 96.5 kilojoules per mole volt times the E0 cell of negative 0.34 volts gives us an answer of positive 66 kilojoules per mole. Alrighty. And number 6, the last one in this section, the standard cell potential for the reaction below is positive 0.134 volts. What is the delta G naught for the following reaction? Alright, so in order to do that, we have to first figure out how many electrons are being transferred. Right? So let's cheat a little bit. You can do the half reactions and get the definite one, but I'm going to cheat. I got 3 Cu zeros becoming 3 Cu plus 2s. So I know that's 2 electrons each, giving me a total of 6 electrons being transferred. So let's see if I can confirm this. I got MnO4 minus, so Mn is plus 7 here, and then over here MnO2, it's plus 4. So that's 3 electron difference times 2, so it's definitely a 6 electron transfer. So I know my delta G is equal to negative 6 times F, which is 96.5 or 96500, depending on whatever units you want to use. I'm going to use kilojoules per mole volt times by the E0 cell of positive 1.34, and the value that I get is going to be negative 776 kilojoules per mole. They kind of sucked here, and I should have gave you units, like should have gave you kilojoules per mole for all these. I didn't, oops, my bad. Anyway, regardless, the digits should have been negative 776, so none of those are the answer. Cool, bring questions, see you in class.